for those at home. Sorry. Apologize in advance. Okay, so product rule. So we got to learn to take the derivative of many different type of functions. Okay, so after you learn all these rules, you have so many rules in your tool belt, you got to look at a function, take a second to ask yourself, okay, what type of function am I dealing with? So you know which rule to apply. And guys, a lot of times, the rules are not tested in isolation. Okay, meaning you'll have to use product rule within another rule. Okay, so does that make sense? So you're going to have to use multiple rules at once. All right, so today we are just focused on product rule. Now, I've taught calculus for 13 years, and I'm going to teach this different than I've taught it, so it's going to take some processing time. All right, so guys, when you have the product of two functions, okay, so f of x times g of x, and you're taking the derivative with respect to x. Okay, so here's the rule, and it's written up here in words. We take derivative of the first times the second, plus the first times derivative of the second. Okay, so you see this? You got f and g, but in this term, you're taking the derivative of the first, leaving the second alone. And then over here, you're leaving the first alone times derivative of the second. Okay? All right, now we're not going to derive that. Okay, if you want to see it derived, go to AP Classroom and watch the video for this topic. I believe this is topic 2.9, and that will derive it for you. Okay, but instead, we're just going to prove to you that it works. Okay, so using what we know right now, without using product rule, using what you learned last week or earlier this week, what would we have to do to take the derivative of this function? Were you going to say something? So we would have to expand this, right? We would have to see it as a polynomial term by term. All right, so help me out with the algebra here. All right, so let's distribute. So what we're doing, guys, is we're taking this derivative without using product rule. Okay. All right, so, and notice I'm labeling everything. I'm not taking a derivative yet, so I'm still calling this y. All right, so 3x times 5, 15x. And then we have 3x times 4x, 12x squared, negative 2x times 5, so negative 10x squared, and negative 2x squared times 4x, negative 8x cubed. And I notice we have like terms, so I'm going to go ahead and combine like terms before I take a derivative. So 15x plus 2x squared minus 8x cubed. And if y'all see me make a mistake, yell at me. Okay, so this polynomial is equivalent to what we were given. All right, so now let's differentiate term by term. All right, so here's what we need to understand. So we are taking the derivative. Okay, the derivative is an operation. We're taking the derivative of this entire equation. So the derivative of y with respect to x, we write that as dy dx. All right, what's the derivative of 15x with respect to x? 15. Derivative of 2x squared with respect to x. And the derivative of negative 8x cubed with respect to x. Negative 24x squared. Everybody okay there? Okay, so this is our derivative, okay, of this given function. Now, we just had to do a couple steps of algebra prior to doing the calculus. Okay? Now we're going to do this same problem, but this time using product rule, just to confirm that product rule works and gives us the same derivative. And then afterwards, we can debate which one is more efficient. Okay? All right, so we're going to follow this rule. All right, so let me erase all my markings here. All right, so I'm going back. Y equals this quantity, 3x minus 2x squared. So when you read this, the product of two functions is derivative of the first times the second plus the first times derivative of the second. So this is the first and this is the second. Okay? All right, so we're going to go straight to taking a derivative on this one. So I label it dy dx, derivative of y with respect to x. All right, so we take derivative of the first. So what is derivative of this first function? 3 minus 4x. And guys, because that is two terms, we have to group it. Okay, so make sure you group if it's multiple terms. All right, so that's derivative of the first. We multiply that by the second. So we multiply that by the second function. Just leave it alone. 5 plus 4x. So that is first, just getting derivative of the first, times the second. So plus, what comes next? The regular first. So first, gotta write small here, sorry. 3x plus 2, just kidding, minus 2x squared. And then I multiply that by derivative of the second, so times 4. All right, so derivative of the first times the second plus the first times derivative of the second. All right, so what we're going to do is we're going to do the algebra just to confirm that it matches what we got without using product rule. All right, so dy dx. All right, so we're distributing 15 plus 12x minus 20x minus 16x squared. And then over here, we'll distribute the 4. So plus 12x minus 8x squared. All right, so combine like terms. So I have just one constant term, 15. And we have 3x terms. So what do we get when we combine 12x with negative 20x and another positive 12x? Positive or negative? Positive. And then I have a negative 16x squared that will combine with negative 8x squared. So negative 24x squared. Did we get the same thing? Okay, so I just wanted you to see that product rule does work, okay? Now, when you have a function presented like this, it is preference. Do you want to do the algebra first, then take a derivative, or do you just want to go straight to the derivative? We could argue which way is more efficient, okay? But there will be some functions where product rule is the only option, okay? So you're going to need to learn this rule and be able to regurgitate it quickly, okay? So either don't memorize it in terms of F and G, because sometimes they'll throw in different letters, okay? So memorizing it in terms of letters just gets confusing. So memorize it in terms of the words. So right here, derivative of the first times the second, plus, make sure it's a plus the first times derivative of the second, okay? Try to talk yourself through it in your head using those words. Okay, but also guys, you got to stop for a minute when you're presented with a function and ask yourself, okay, what rule do I need to use? Because I'll tell you, the most common mistake is not recognizing to use product rule. I'll grade an assignment on those my kids should have used product rule and didn't. I'll ask them what's product rule. They can recite it to me. So it's not an issue of not knowing product rule. It's an issue of not recognizing to use product rule. Okay? So let's look at the second example. Can I erase all this? All right, so y equals 2x times cosine x. Okay, I emphasize the times so that I recognize it's a product. Minus 2 times sine x. All right, so we know if we are presented with multiple terms, we just differentiate term by term. So for the first term, do we have to use product rule? Yes, that is a product. I have to use product rule. And there's no way to eliminate that product, okay, like we were able to do in that first example by distributing. All right, so we're taking a derivative. So derivative of y with respect to x, dy dx. All right, what's product rule? Derivative of the first times the second plus the first times derivative of the second. Think about that. I say it differently in my class, that's why. Okay, so derivative of the first. What is the derivative of 2x? 2 times the second. Leave it alone. Plus. So we did derivative of the first times the second plus the first 2x times derivative of the second. So what is the derivative of cosine x? Negative sine x. Now guys, be careful how you write this, because if I just write it like this and say, all right, there's my negative sine x, does it look like I'm multiplying? No, so be careful. So make sure you group that so it's clear that you're multiplying 2x by negative sine x. So derivative of the first times the second plus the first times derivative of the second. But that was just the derivative of our first term, so now I move over here. All right. Minus. Okay, can I put a pause on this problem real quick and come over here on the side? Do a little. What if I had a function that was just this, 2 sine x, okay? Now, do I in fact have a product? 2 times sine x. Anytime you have a product, you can use product rule, okay? So let's work this problem real quickly using product rule. What's product rule? Derivative of the first. What is derivative of the first? 0 times the second. 0 times sine x plus the first times derivative of the second, cosine x. So you see how that first term goes away because it's being multiplied by 0? All right, so the purpose of this is for you to understand, when your product, when one of the functions, when one of the factors of that product is a constant, you don't have to use product rule. You can, okay? It will work. It's just probably not the most efficient route. So when you're looking at this as a product, just take a minute and notice, okay, my first function is a constant. I don't have to use product rule. So all right, so remember we already took the derivative of the first term, so now I'm moving here. So I just leave the constant alone, minus 2 times derivative of sine x. What is the derivative of sine x? Cosine x. All right, can I clean this up? Now, if it were a free response question, could I stop right here? Yes, completely unsimplified. You walk away, okay? Free response question, you do what they tell you to do, and you move on, okay, for 2 reasons. 1, you're taking a time test, okay? You did what they said, you got the correct answer, move on. 2, going further, you might talk yourself out of the correct answer. So my derivative is correct. What if I try to clean it up incorrectly? Then I've talked myself out of a point that I would have had otherwise, and I wasted time doing so, okay? So this is what we call our free response answer. But on a multiple choice, you will have to be able to clean it up to make it match one of your answer choices. All right, so how can I clean this up? How can I simplify? So the 2 cosine x, and I'm taking away 2 cosine x. That combines to be 0. We have 2x times negative sine x. So negative 2x sine x. That would be our multiple choice answer. Good? All right, what's product rule? Okay, perfect. Okay, so you'll get the hang of it because you'll have to recite it over and over when you work these problems. All right, so when I look at this function, Okay, I have the product of 3x squared and tangent x. So y equals 3, or f of x equals 3x squared times tangent x. Do we have to use product rule? Yes, because both of my pieces, first and second, have variable components. Okay. All right, what's product rule? See, you could think of it. So, too many words. Okay, as long as you can apply it, but I really encourage you not to memorize it in terms of F and G. Okay, a couple years ago, they threw a problem on there with different variables, and you could tell some kids were getting, or different letters, and some kids were getting confused. All right, so f prime of x, derivative of the first. So what is the derivative of 3x squared? 6x. So derivative of the first times the second. Tangent x. Plus derivative of the first times the second, plus the first, 3x squared, times derivative of the second. What is the derivative of tangent x? Secant squared x. Do it. What's ISN?
It stands for Interactive Student Notebook.
Okay. I was thinking interactive notebook, but I was like, there's an S in there. Okay, so guys, that's my free response answer. I have my derivative, I walk away. Okay? Multiple choice, what do you think you would be expected to do? Sometimes they'll say, okay, not only take the derivative, but evaluate it at a certain particular value of x. Okay, so when you're working a multiple choice question, okay, every time, so you take a derivative, and then you look at your answer choices. Okay, if this is not there, okay, if you don't see an answer choice that looks like this, don't get frustrated. Okay, my students throw their pencil down, get all upset, and I'm like, you're right. You're just not done. So what could I do to simplify this? Well, I don't really have, these are just individual factors. Yeah, I have two terms, right? So what do these two terms have in common? What factor do those two terms share? X and what else? I'm going to do this. Hopefully you don't have to do this, but 6, I can write that as 3 times 2 times x times tangent x, yes? Plus 3 times x times secant x, secant squared x. And then I can look and see, okay, what factor do they share? What factor do they have in common? Okay, they share a 3, and they share an x. So we can factor out a 3x. So 3x. So when I divide out that 3x, what's left in that first term? 2 tangent x. And what's left in our second term? X secant squared x. All right, so on a multiple choice question, most of the time you will have to factor. Everybody okay? I have no idea because the right there. And then I just copied it down. Somebody noticed that because I heard somebody whisper something. Y'all didn't tell me. I told you, if I make a mistake, y'all gotta yell at me. Sorry, please. Okay. Thank you. All right, y'all want to try one? You guys try this one at your table. No.
No negative self-talk. talking to this one.
Do you want me to show them the thing? Okay, be careful. You gotta have an argument. So it's secant x times tangent x. The way that you have it written, it would be like the secant of tangent x. So it's secant x tangent times tangent x.
It's just a yeah. Very good. You got yourself. Why isn't anything?
That's perfect. I always like to practice the factoring during class just so you get really efficient. Okay, so we have a function that is the product of x cubed and secant x. All right, so we have to recognize that that's a product, okay? Both factors of that product have variable components, so I have to use product rule. All right, so product rule says we take derivative of the first, 3x squared, times the second, secant x, plus derivative of the first times the second, plus the first, times derivative of the second. What is the derivative of secant? Good. Secant x times tangent x. Okay. Both trig operators have to have that same argument, x. All right, so that is our free response answer. Okay, multiple choice. Most likely you will be expected to factor. All right, so we have two terms. What's a common factor within these two terms? Nice. So x squared times secant x. When we divide that out of the first term, what's left? 3 plus x tangent x. You guys remember, addition is commutative, so when you're trying to make it match one of your multiple choice, you can always have this written as x tangent x plus 3. All right, so a lot of you were referring back to your notes for those derivatives, which is good, right? Helps you learn. All right. Who has your trig derivatives memorized? You do? Okay, she knows them, so when Miss Finnan's giving you a quiz, just remember, she's the one that knows them, so you just go, psst, psst. All right. Psst. Right, because she's going to use, what's the answer, right? Okay, so somebody showed me this a long time ago. I thought it was silly. I was like, I'm never going to use that, and then it stuck, kind of like your factories eat people's legs. That went through my head the other day when I was going over the test question and I was going through the order of dominance with my kids. I didn't say it out loud to them, but in my head I was saying, factories. Okay, so I always hear these things. Okay, and this is not mine. I didn't come up with this. I'm not that clever. But the P is just in the way. So secant x, tangent x. So ignore the P. All right, so the derivative of secant is secant x times tangent x. Okay? The derivative of tangent x is secant x times secant x. Okay? I didn't think I would need that, but after somebody showed it to me, that's what I've used. So secant times tangent, derivative of tangent, secant times secant, so secant squared. Okay? And remember, all of your co-functions have negative derivatives. So you have 6 trig functions, 6 derivatives, 3 of them are positive, 3 of them are negative. Your co-functions have negative derivatives. All right, moving on. And I always hear that when my kids are testing, and I look up and I realize they're just reminding themselves. They're not actually trying to cheat. Don't do that. Okay, so sometimes, guys, we'll be presented as with a function, okay, just in terms of functions. And you are just given a snapshot, okay, of values of that functions and their derivatives at certain values of x. All right, so we're going to use this table of values to find not only the derivative as a function of x, but then evaluate it at the given x value. So, table of values, snapshots of f and g, and their corresponding derivatives. All right, so we have h. Read this function to me. F of x times g of x. You hear the times? Get used to saying that times so you recognize this is a product. We have f of x times g of x. All right, so I have to use product rule. H prime of x. All right, what's product rule? Perfect. Okay, derivative of the first. Derivative of the first. So f prime of x times the second plus the first times derivative of the second. All right, so we want to go further on this one and evaluate this derivative at x equals 2. So f prime of 2 times g of 2 plus f of 2 times g prime of 2. And now I just pull these values from the table, guys. So f prime of 2, given in this table, is 6. G of 2, 3, plus f of 2, negative 1, and g prime of 2, negative 5. On a free response question, can I stop right here? Okay, yes. Do I want to? Yes. Okay, you can't stop here. You do have to make those substitutions. You do have to extract those values from the table and make the substitutions, but you do not have to do the arithmetic. Okay, so this is your free response answer. Okay, let me say it like this. We did evaluate. Okay, so we are evaluating. We not only found the derivative as a function of x, we are evaluating that derivative at x equals 2. When the only thing left to do is arithmetic, you can stop on a free response question. Now, yes, because some students are like, oh, I'll just stop right there. No, you do have to extract those values from the table. Yes, so this is your, they call it safe stop. The last thing I have to do is arithmetic, so I can stop right here. There was a question a couple years ago, and it involved doing 3 times negative 2. And no, it was negative 3 times negative 2. And you wouldn't believe how many kids told me that was negative 6. But remember, you're in a time situation, right? You're watching the time, you're getting anxious, like stuff like that happens. So that's why you want to just, you know what, I have the answer, let's walk away, right? You're saving, you don't want to waste time and you don't want to talk yourself out of a point. And it's painful. Like, oh, you had it, and then you lost it. Okay? But does that mean you aren't expected to do arithmetic? No, because multiple choice, they will not leave the answer like this. So what's our multiple choice answer? 23. Okay, can I skip part B for now and go on to this graphical question? No, you said no. No, really? Which one? So you want me to do that? I forget what time this class is over. Okay. All right, let's go do this one. Let's do this one. Okay, so we have a graphical question. Okay, it's very similar to the previous. On this one, they gave us values of the function and their corresponding derivatives, okay, and a table. Here, they give us a graph, so we have to work a little harder to find these values. All right, so we're looking at the graph of f and g. I like to highlight them so I don't get confused. So we've got f and g. All right, so here we have h. H of x is equal to f of x times g of x. And we're tasked with finding the derivative of h and evaluating it at x equals 1. All right, so do we have to use product rule? Yes. Okay, so what's product rule? See? Derivative of the first times the second plus the first times derivative of the second. All right, we need to evaluate this at x equals 1. So we need f prime at 1, g of 1, f of 1, and g prime of 1. All right. So there's 4 values I'm going to need to pull off of this graph. We need f of 1, and we will need f prime of 1. We need g of 1, and g prime of 1. All right, what is f of 1? 3. And what are you doing? You're just reading a point off the graph. Okay, at x equals 1, the corresponding y coordinate is 3. And because it's an intersection point of f and g, I'm going to go ahead and write down that g of 1 is also 3. All right, so now I need f prime of 1. So how do I get that value? What is a derivative graphically? There you go. So when I'm talking myself through this in my head, I'm saying, okay, I need the slope of f at x equals 1. Because a derivative graphically is slope. And we have a piecewise linear function, so we can find the slope of each segment. And likewise over here, when I need g prime in my head, I'm saying, okay, I need to find the slope of g at x equals 1. All right, so what is the slope of f as we pass through that x coordinate of 1? Slope of f right here. So isn't it 2? We go up 1, up 2 over 1. Okay, 2. We do vertical change divided by horizontal change. No worries. It happens. Rise over run if you want. Okay. It's okay. You're allowed to forget things. Just relearn. So vertical change divided by horizontal change. That is an increasing function, so its slope is positive. All right, so then I need g prime of 1. So what is the slope of g at x equals 1? Negative 1. All right, so let's make these substitutions. So f prime of 1, we said was 2, times g of 1, 3, plus f of 1, 3, times g prime of 1, negative 1. Can I stop right there for free response? Yes. Do I want to? Yes. All right, multiple choice. We would be expected to do this arithmetic without a calculator. It's 3. Good. So, free response answer, multiple choice answer. Okay. All right. Let me see what's on the next page. Oh, yeah. Let me, I'm going to skip down and focus here. All right, have y'all had any conversation about second derivatives?
Yes.
Do it again, right? We have a first derivative, which is the derivative of your function. Second derivative, derivative of the original. All right, so let's talk about notation.
They were asking how far you can go.
Okay?
Like, I'm just curious. I know you're going to show that, but like, fourth and fifth, but like, how many, I don't know. Is there a thing where it's like derivatives to the
Mhm. I can continue. Okay, and then in later on in this semester, we'll learn how to use derivatives to describe behavior of graphs. So the first derivative tells us something about the function. The second derivative tells us about the function. And then in Cal 2, you'll go even further. Okay, so a lot of times in this course, okay, first and second derivative is typically as far as we go. All right, so f prime of x. So let's take a first derivative. What's the derivative of 8/3 x cubed? 8x squared. What's the derivative of negative 5x squared? Minus 10x. Minus 7. What's the derivative of 1? Why? 0 is a constant. So the rate of change of constant is 0. All right, so that's our first derivative. Graphically, it tells us slope at a point. Contextually, instantaneous rate of change. All right, let's take a second derivative. So we call this one f prime of x. Second derivative, f double prime of x. All right. Nice. 16x minus 10. That's our second derivative. Let's go again. What's the third derivative? 16. Just for fun, what's the fourth derivative? What's the 100th derivative? There you go. Yep. Because once it's 0, okay, every derivative beyond that is also 0, right? Because 0 is a constant, its derivative is a constant. Now, guys, the notation. So f prime, okay? F prime of x, f double prime of x, f triple prime of x. After the third prime, we don't do f prime, 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 prime. At that point, you indicate the order of the derivative by a number, and it's typically presented in parentheses. So our fourth derivative, we write it like this, of x, would be what? 0. And like I said, what's the 100th derivative? Also 0. Okay? So after the third prime, you start writing the order of the derivative as a number. Okay, let's talk about this other notation, okay? Because notation is huge on the AP exam, okay? And you will lose points for incorrect notation. All right, so I'm just going to make up a question. I'll change color. Something pretty straightforward. Y equals x cubed. You don't have to write this down. You can just watch if you want. So when we take a derivative, you need to understand that the derivative is an operation, okay? And I perform that operation to both sides of the equation. So we're taking the derivative with respect to x of this entire equation. So that's where this dy dx comes from, okay? So my first derivative, dy dx, would be equal to what? 3x squared. And then, if I want to take a second derivative, I am taking a second derivative of this entire equation. To make some room here. All right, so the notation, we do d to y over dx. And those are not exponents, okay? This doesn't mean d squared y over dx squared. But the reason this is just a notation, okay, that's already put in place for us. But do you see there's two d's here, which is why the 2 in the numerator goes after the d, versus in the denominator dx dx. So we have it here. Because if you write it out here, okay, if you write dy with your 2 out here, that's incorrect notation, and you would be docked a point on the AP exam. So what is the second derivative? 6x. And then if I wanted to take another derivative, I would have to take the derivative of the whole equation. So we would write that. So we just increase that little index by 1. All right, so I wanted you to understand why it's written in that way. So what is the derivative here? The third derivative, 6. If I continued, what would be the 16th derivative? 0. Okay. Everybody good? What time? How much time do we have? All right, we should do the trig problem. So we like trig. All right, so let's go back up to this one here. All right, so this time we're not just taking a derivative. We're saying, write the equation of the tangent line. So what does that trigger in your head? What's the first thing you're writing on your paper? We need a point, the point, and we need a slope. The point comes from the function, right? The slope comes from the derivative. So they're telling us we're going to do this at an x-coordinate of pi over 3. So we need to find the corresponding y-coordinate by substituting the given x-coordinate into the function, and we find the slope using the derivative. All right, so f of pi over 3 would be 8 times the sine of pi over 3 times the cosine of pi over 3. All right, what's the sine? What's the sine ratio of pi over 3? So 8 times square root of 3 over 2. And what's our sine rate or cosine ratio of pi over 3? 1/2. All right, clean that up. What do we get? 8 divided by 4. 2 square roots of 3. Good. So our point, pi over 3, 2 square roots of 3. All right, now we need a derivative. So we've got 8 sine x times cosine x. We have to use product rule. So I would go ahead and just look at that as our first 8 sine x and cosine x as our derivative. As our second function. All right, what's product rule? Okay, so derivative of the first. What is the derivative of 8 sine x? 8 cosine x. I'm so sorry, guys. I shouldn't have got in the middle of that problem. All right, so keep practicing reciting that product rule in terms of first and second.